Okay. Hi, everyone.
Hello.
Oh, hi.
Hello.
Oh, perfect timing. So I guess.
Can people hear me?
Oh, yeah, I can hear you.
Yes.
Yes.
People hear me now?
Yeah, I can hear you.
Okay, sorry. I'm just trying to find the mute button because I am in a fairly crowded place. I think I found it.
Okay. Cool. Okay, sounds like everyone's in this call. Needs to be. I think the only. Oh, okay, Liam is here too. So there's.
Yeah, how's it going, guys?
Sorry.
Yeah, just saying, how's it going?
Oh, hey. So I guess it's in this call is BakeX, Tendermint, L4, Omise Go, EF, Ethereum Foundation, and I know I'm missing a Consensus, right? Is that everyone? Cool, awesome. So everybody's here. So I guess, like we said last week, this call is mainly about Q&A, getting up to speed, I think, in sort of everybody talking things through, more of like an open, lively discussion. And it's sort of like the thinking of this is maybe we can, all get each other up to speed so that while we're doing the implementations, we're sort of on the same page. And then maybe in the coming weeks, getting more into brass tacks on individual ideas. Carl, do you have anything to add when it comes to thematic elements?
I think that sounded great. Just Q&A, hard questions.
Okay, and I think.
By the way, Carl, did you remember to invite the Taiwan people? I think I emailed you about that. If not, is the call going to get recorded? Just want to make sure that you can get it if there's an opportunity for them too.
Yes. I did not. I apologize. But I will.
Well, is the call recorded?
Yes, the call is recorded.
Okay, great. I'm sorry. This is if you go to github.com/Ethereum-plasma, there's a totally separate Taiwan team that's been starting to make a plasma implementation over the last few weeks.
Oh wow, cool. Which team is this?
I don't think you've met them before. They don't really have a name yet other than Ethereum-plasma.
Ethereum-plasma. Oh, that's awesome. Okay, cool. Yeah, let's, and I think for anyone listening in, I think the general thematic idea is if you're pushing code, that isn't just like a code port, like a one-for-one code port. If it's actually working on code on this, I think definitely open to joining the call or doing contributions when it comes to design and architecture. So definitely, let's bring them in. Okay, cool. So I think one thing that we can also loop back on is the BankX team. I think you guys did some recent thinking when it comes to certain kinds of designs. I hadn't had a chance to reply to your email, but could be a good venue to discuss or update on this as well before we jump into like Q&A. Is there someone from the BankX team here? Oh, actually, they might not be here. Oh, oops. Okay, I thought they were here. Anyway, okay, let's just start discussing them. Maybe I'll ping them and see if they can get in as well. Okay, maybe David, do you want to talk about like accounts and stuff like that while we're ping them, I guess?
Yeah, totally. So the main kind of what I've been working on primarily since we last talked in terms of implementation, I've just been kind of doing the child chain and then carving out a command line interface for people to kind of connect with the child chain and deposit, withdraw, and send transactions. And in terms of kind of like going forward and past that, I think the next easy step is adding denominations for different types of currency, and basically trying to support accounts in as simple a way as possible. which at least right now, the proven way is the way that Vitalik mentioned to me, which is basically doing 2 UTXOs for every transfer. I'm kind of hoping there's an easier way, but yeah, as of right now, with the requirement that confirmations need to happen to basically prevent the operator from withholding and sabotaging people getting their money back. Right now, separating transactions that have gone through from confirmed transactions is an ongoing issue. Yeah.
And one thing to add in terms of thinking when it comes to accounts is, I know I've mentioned this before, but maybe not on this call, is that if you want an account type model, there's a lot of security considerations when it comes to ownership of the accounts. Currently, the most secure way to do it is to have an actual owner of every account. And what that means is that you can't easily do sort of DAO type constructions in specific accounts. If you want DAO type construction, it probably needs to be part of the chain itself. And basically the security presumptions presume that the economic incentives to continue running the chain with some type of token bond is basically underlying the security properties of that. And there's basically no other security guarantees behind that because of block withholding attacks. Because if you have an individual, then they can take action, individual account owner, then they can take action in the event of block withholding. But if there is no account owner, then sort of how do you deal with that kind of thing is sort of the thinking. Unless there's a new way to do it, but that's how I see it in terms of perspectives, you know?
Right. What if we can, okay, I'm just trying to figure out conceptually, it's surprising to me that an account, like a DAO account, wouldn't be able to withdraw. Would it be possible to just say, anyone to say, hey, for this account, yeah, okay, you would need some kind of unanimous decision from that DAO account to tell, and that's the problem, right?
Yeah, so first of all, 2 caveats to the owner thing. One of them is that, yes, the owner can be a multi-sig, and the other is, yes, the owner can change between operations. So if that helps somewhat, then yes. But in general, right, the principle is that the state has to be broken up into units such that each unit gets mapped to some kind of logical beneficiary, where if that particular unit of state were to become corrupted in some way, only the beneficiary would end up losing out as a result.
Vitalik, what was your point number 2? I didn't catch it, sorry.
That the state has to be broken up into units where every unit of state has a logical beneficiary, such that if something happens to that unit of state, then only the beneficiary loses.
Oh, yeah. I didn't consider that at all. Yeah, definitely. I guess you could have one where the current state has no quote unquote owner, but has a deterministic beneficiary under that context. Yeah, I think that's another way to look at it. Yeah, I didn't consider that. So it's sort of if the chain halts or in some way, you can sort of move on and sort of distribute out the value in a way that sort of makes sense. Yeah, that's a good point. Okay, cool. So I guess, David, is there any I guess maybe I think I mentioned last time to you personally, but I think if there's a way to review the design of the account model, I think that could be really fun. Because I actually haven't done much thinking about this myself, so I think it's something which I think is really interesting for everybody to see. But yeah, I don't know, we could just open this up to Q&A, current thinking when it comes to
so David, what's your thinking on how will the child chain trail the Ethereum consensus?
Oh, David, you're muted.
You're muted, I think.
How the child chain will trail the Ethereum consensus?
Yeah.
Right now, I think like because Ethereum's still proof of work, basically is going off like block confirmations. In terms of like after X number of block confirmations, that's right. Is that what you're asking?
So like,
Wait, but
no,
we're talking about the child chains, right?
yeah.
So, what do you mean?
Ethereum is the root chain.
Yeah.
Like, how does the child chain find out about the latest state of the Ethereum chain?
At least right now, I'm doing it with like Web3 JSON RPC communications between the child chain, where the child chain is basically pinging the root chain.
Okay, right, yes.
And it's a POA type construction, right?
Yeah.
So it's simple when it comes to the data communication.
Yeah.
Okay.
So is it like direct connect to the host, or is it like a peer-to-peer type connection? I assume it's a direct connection to the host, right?
Yeah.
Okay.
Cool. Yeah, right now, because the child chain is a server basically, and so yeah, it's just pinging.
Okay.
And then I assume, David, does your child chain right now support more than one signer, or is it just like a single signer chain?
Single signer. Or okay. Wait, do you mean by like signing off on blocks or UTXOs?
Off on blocks.
Yes, single signer proof of authority.
Okay. All right. I'm guessing you're not a Golang programmer, but if you were, then we have the Cosmos SDK. It's a pretty good starting point now for developing additional modules. So if you are a Golang developer, please check it out. We will be implementing, so we have Ethermint, which is Tendermint plus Go Ethereum. And we're gonna inject the SDK in between those two layers so that Ethermint can take advantage of SDK features. So the staking for our hub and our IBC and all that, that's all going to be built into the SDK as modules of the SDK. So yeah, our Plasma integration will be like an SDK feature.
Module.
Yeah.
So are you talking about Ethereum interaction, or are you talking about just in general?
I'm talking about, well, this would be for Ethermint. So I just talked about how Ethermint, which is separate from.
Oh. Got it. So like on Ethermint, if you wanted to, let's say deploy a Plasma chain, then it'll become easier. That would be pretty exciting, especially for like the more enterprise.
Yeah, but we should also, like, as soon as we get separately, we're also developing, we're working on developing the Solidity contract for the, bridge to Tendermint or Cosmos SDK. So that means we will be able to shard out, so connect mainnet Ethereum to any of our Ethermint instances.
Okay, cool.
So essentially PEG zone.
Yeah, so it's the PEG zone that we talked about.
Okay, cool. Did two people just join, or one person just join? Peter.
Hello, everyone. Peter Korolev from BankX is here. Okay. And today the Roman, the main senior developer of Plasma, instead of Alex Vlasov, will be with me.
Got it. Okay, cool. So Poma is the other person on your team as well.
Yes, awesome. Roma is also from BankX. Is our senior developer.
Okay, nice to meet you. So we were just talking about Jay when it comes to building Tendermint consensus in Solidity. And I think this is fairly interesting because for the rest of the people on the call to get up to speed, because right now we were just discussing how David's implementation presumes POA, proof of authority, where there's just one entity signing blocks and one entity who you send transactions to, and that gives you like a good usability, but eventually long term you might want some type of distributed consensus mechanism when it comes to creating Plasma blocks. And Jay has someone on his team working on possibly using Tendermint as a method, right? Is that right, Jay? The summary?
Yeah, that's right. So we're working on the Solidity contract that will allow mainnet Ethereum or any Ethereum chain, but mostly mainnet Ethereum, to communicate IBC with another Cosmos SDK application. Yeah.
That's really cool. Is who's working on that right now? Like, or is it just getting started?
There's several pieces going on. A lot of people are working on the SDK now. I need to start working on the Ethermint SDK injection. So taking our existing Ethermint and putting the SDK in there. And then June and others are working on the Solidity side. So there's a lot of pieces that I need to.
Yeah, because it's like multiple interacting pieces. Yeah.
Yeah.
And then eventually it'll hit the P2P layer too. Yeah, that's a lot of pieces, and it's a pretty cool undertaking. No, well, I guess the P2P side for Tendermint is already there. So
that's already done.
Yeah. Okay. Cool.
And like another thing we're working on is that that you can have staking contracts on Ethereum, and that informs the validator set on Tendermint. So that you can, so essentially that you have a Tendermint chain which trails the Ethereum consensus to build its own, to inform its own validator set.
That's what we talked about, Jerry. Yeah.
Yeah. Okay. So how do you do enforcement under that type of construction? Like, in the event of failure, they lose coins. They lose like ERC20 tokens is the presumption. Then they get slashed based on the law.
What kind of? It depends on the failure.
Oh.
So like if so what happens? So like what can happen if the consensus on the child chain breaks? And by the way, so this is only about staking on Ethereum. This isn't moving tokens to that staking contract. So like in the case of consensus failure on the child chain, you'll just have an automatic, people can just try to withdraw the tokens they've delegated. And as long as the consensus on the child chain is live, they can challenge it and they burn some fee or something, if you want to withdraw. But if the consensus fails, people, everyone can automatically start unbonding. Yeah.
Okay, that makes sense.
Yeah.
Okay,
so if the consensus is
like validator double signing type of thing.
Yeah, so that we would need to get some sort of way to verify the proofs of double signing into Solidity to slash people in the staking contract.
We might not need that if we just say that, say, 51% or something between 51 and 67% need to sign off on changes to the validator set, and just say, instead of putting evidence in the Solidity contract, just say, well, the supermajority here agree that these people should be slashed. It's potentially less. It is less secure because there's no accountability, but it's a lot simpler to implement and get started.
Okay, cool. Okay, that makes sense. Are there any other updates when it comes to? That's already a lot. Yeah.
Yeah. No, we don't have any further.
Yeah, that's already a lot. That's really cool. So in terms of thinking on my end, I've been thinking a lot about the certain types of withdrawal events. I think it's a good policy before. Obviously, we're all doing. But
could you repeat that?
Oh, Adrian, you might want to mute yourself as well. I think there's a little bit of background noise for you. Oh yeah, so essentially we've been doing a lot of, I've been doing a lot of thinking when it comes to withdrawal events and stuff like that. And I think we're all doing a lot of testing, and I think this is probably not going to be relevant for at least another, I don't know, I want to say 3 to 6 months, but it's important, I guess, to get it out there early. I think mass withdrawal events is definitely a mechanism that, I'm concerned about. I think with prior work on my end, Lightning, there's already mitigation to, and this affects state channels as well, and ideally should be in most state channel implementations, whereby effectively you pre-reserve space, that can be used in the event of essentially certain types of systemic issues. And I think basically channel type events, I think you can basically fully mitigate it. I think the documentation with that is in my extension block proposal. Right now, I'm working on research of mitigating this on the plasma side to the same extent. On the plasma side right now, there's no perfect mitigation for certain types of systemic events. And basically, the best thing you could do, I think, right now is essentially you set some type of clock that gets stopped. Essentially, I think the parlance in the space is called a time stop. I think Greg was the one that came up with that. And essentially, the design for that is if the gas price goes above a certain value, the clock doesn't move forward in terms of elapsed time. And that allows basically the withdrawal mechanism to sort of get delayed until the gas price goes below a certain time. The problem with this is that if the gas persistently is above a certain price, then that can create problems. And you may want to then trigger like a third emergency type event, whereby some cosigner agrees to basically unlock the coins as under these conditions. So that's sort of like an emergency if the fees are persistently high, that you're basically delegating a backstop to some basically some authority. Do you guys get what I mean when it comes to this type of construction? Yeah. I don't know, like, do you guys have any thinking with this, or like, I don't know. I just think like this is a good backstop in the short term. I mean, longer term, there might be some group signatures or ZK SNARKs type construction that should be able to resolve this. But as of right now, that's probably a pretty good, backstop, I think.
Yeah, I think actually Nate Rush was actually working on this for a little bit over the summer.
Oh, okay. Who's Nate? I don't know if I've met him personally.
I think you have. He's works on he works with Vlad on Casper, on CBC Casper.
Oh, yeah. I think I've met him. Yeah. Okay, cool. Yeah, I should reach out to him then, because yeah, this is a topic I care about. I think it took me, it basically took me probably a year to figure out how to resolve this with channels. So I mean, the plasma stuff, ideally there's like a better solution than this, but I think in the near term, it's basically a good backstop. So I think like finding someone to collaborate with this is definitely something I'm looking for. On the research side, that's sort of what I've been up to. And in terms of like design for this, I can make a quick write-up in terms of like sort of what the backstop looks like, and I guess where we're headed in terms of a better solution. I think you could build like a solution using SNARKs, right? Where like you basically make it so that you can only do transitions if the parties sign off on it, but I don't know how big the SNARK circuit would be. I mean, the ideal is that we do it without any presumptions of trusted setup. But I think worst case scenario, hypothetically, I think you could do a SNARK circuit. It might require recursive SNARKs. That's what was tripping me up. What's the progress on recursive SNARKs anyway? This might be a bit of a diversion for everyone, but like, I don't know whether everyone knows this. I guess if Elaine was in this.
I don't really know much on what the concrete progress is. I mean, I know theoretically it's totally possible, so probably not. So not with any of the curves that Israel or Zcash use. I'd recommend just popping over the question to Q&A.
Yeah. Okay.
Or Elaine.
Yeah, I'll do that. Okay, cool. So that's sort of what I've been thinking about. I don't know if anyone has any questions or something like that. That'd be good. It feels like this is a low question day, and we're dedicating it to questions.
I think one thing that might be good is we have this minimal viable plasma, and that's a very like or seemingly well-defined spec. And so if anyone has like lingering kind of uncertainties around minimal viable plasma, now is definitely a good time to kind of clear up the misconceptions.
There was one thing that was brought up on ETH Research, I think just a couple hours ago, which is that in order to send a transaction, the transaction needs to contain the confirm of of the UTXO inputs of the UTXOs that are inputs to the transaction. So like if A sends to B and then B sends to C, then the transaction that's B sending to C has to get to confirm from A. And that wasn't technically in the transaction format, and we should probably add it into the transaction format.
Sorry, can you repeat yourself? I think like there was some background noise. I couldn't hear all of that.
Yeah, so basically if A sends to B and then B sends that UTXO to C, then the transaction from B to C has to contain the confirm message from A, right? And if there is no confirm message from A, then like B should not be able to spend those points because they're technically still A to exit if A1.
Yes.
Yeah.
So basically, spending of unconfirmed coins is the
yeah.
Is
Right. So in order to spend a coin, the coin has to be confirmed, but then the transaction that does the spend has to have a data field that contains the UTX that contains that confirm, and the current minimum viable plasma spec doesn't do that, so that needs to be added.
Oh, okay. Oh, weird. I should have been able. I should have caught that when I read it. I'll read it. I'll reread the spec much closer because that kind of freaks me out that I didn't catch that. That's definitely a good point. Jeez. Okay. Under that construction, is the thinking that it shouldn't, as part of a consensus rule or effectively, peer-to-peer consensus understood policy, that one should not include in a block anything unconfirmed? I think that's a reasonable policy, right?
Yeah. So I think the easiest way to actually think about and implement it is by just requiring the confirmation to be part of the transaction body. So that way there's no kind of separate concept of confirms that you need to worry about in the client.
Yeah. Because I think if you allow unconfirmed, there's no inherent problems, but I could see some problems coming up if you start confirming those unconfirmed. It's a mess. Yeah, that's a good point. Yeah,
isn't the confirmation separate from? So wait, I'm confused. So on the plasma chain, if there's A, B, C, and then A had in the plasma chain, but then A decided to withdraw, but then, I forget A, B, C, just A and B. So A has coins on plasma, and then A withdraws his very old coins on the main chain, and then suddenly A tries to spend by giving it to B simultaneously. Is that the situation we're talking about?
Effectively, the issue that we're talking about is, I think we're overloading words here. So I think maybe we should have like a definition section as part of it. I think when we were working on the Lightning spec, we had to make definitions because we all had different words for everything. And right now the issue is that we're overloading. Basically, there's a confirmation of basically having the plasma block being committed onto the Ethereum chain, right? We're not talking about that. We're talking about, well, implicitly we're talking about that, but we're not directly talking about that. We're talking about, on a fundamental level, we're talking, what Vitalik brought up was that when A sends a transaction to B, we're using a two-phase commit where the transaction goes in, and correct me if I'm wrong, Vitalik, that when A sends to B, there's a transaction that goes in, and then there's a commitment, there's a prepare and a commit. And the commit is the one, if the commit doesn't go in, then effectively the transaction is confirmed.
So I don't really think of it as commits kind of quote going in. I think of, because theoretically the commit could be to just go from A to B directly. Like it could be published on Whisper because it doesn't really matter, but it's like the model still works if commits are not globally known, and we can't assume they're globally known because the actors like could be adversarial. So like the way that I think about it is that the general payment process is step one, A signs a transaction, and with like input UTXOs from A and output UTXOs from B. Step two, the miner, so we'll call him Charlie, it takes the transaction, includes it in a plasma block, And step 3, Charlie publishes a transaction containing the block header of the Plasma block to the Ethereum main chain. That gets confirmed. Step 4, upon seeing that got confirmed, A sends a confirm message to B. Now, in order for B to accept money as his own, so in order for A's kind of like client interface to show coins as belonging to him, what needs to happen is, number 1, there needs to be a transaction included in a Plasma block that has been published to the Plasma contract, where that transaction sends the coins to B. Number 2, every that block and every previous block must be fully available and fully valid. And number 3, Bob needs to be in possession of the confirm message.
Okay, thank you. Looks like I need to read more.
But basically, this is to deal with certain kinds of proving. Basically, you're making an attestation that your block, the block which your transaction went into, was not withheld. And because you're making an attestation that it wasn't withheld as part of the commit in a way, I guess maybe that's not the right language, but in order, as a result of making that attestation, you're basically revoking your right to claim that on chain the block is being withheld when you withdraw.
Mm-hmm. Got it.
And it's to deal with block withholding or non-block withholding in every single possible state transition.
Right. So let me try to rephrase just from my own understanding. Totally my fault for not reading enough of the minimum viable plasma. But we've been talking about A something to be in the plasma chain, and the confirmation is to prove to B, say, or the plasma chain, that A's coins can be sent to B because the block was confirmed where A received those coins.
Yeah, and by confirmed, it was included in the main chain.
In the main chain, yeah, right. All right, thank you. Awesome.
Cool. Any further questions from other teams? Maybe the BankX team wants to give an update, possibly?
Yes, as for us, I think we can get a little bit more discussion about snarks for the next meeting. And about our Plasma implementation, I would like to ask to check the review, because we made some fixes in the implementation from our last meeting and fixed the security issues that was related with the transactions in the main Ethereum, that atomic switch that we talked about. So we made the implementation. I would be glad to review from some of you guys. So yeah, and we are currently working very hard on that.
Oh, cool. So yeah, I think like you guys reviewed with the withdrawal mechanism, right? Is that what was the functionality?
Yeah, I think I can clarify a little. I sent an email with a link to the GitHub for latest version of the contract for everyone who was in the mail list. Just to get, so we fixed an issue with instant withdrawal. There is a clarification how it works now, like quasi-instant withdrawal, which still requires a 1-week delay. Also, if you didn't touch your coins for 1 week, you can prove and withdraw immediately. So this is the only change we made. So, for example, I send you a coin, and then you don't do nothing with the coin for like a month or so, and then you want this coin back to main chain. In this case, you can do it immediately. Otherwise, you have to wait for a week.
If you did it immediately, you need a proof that the coin has not moved.
Yeah.
So I don't think that immediate withdrawals from Plasma are possible without snarks. Precisely because you always need to have the challenge period
Yes. This is the
so
reason.
that's why we have 1 week.
Yeah. This is the reason. In a contract, you can like burn your coins on Plasma and prove to the contract that, for example, the previous transaction that you are burning was there for more than a week. So if no one challenged it, it should be valid.
Okay, so there's a 1 week delay and not instant, correct?
Yeah, so it's implied delay. So if it passed already, you can do it immediately. But otherwise, well, you have to wait for a week at least.
So the presumption is that you pre-lock your coins for withdrawal on chain. Is that the presumption? And it's a week has passed.
Yeah. Well, so the presumption there is so it works like this. So I send you a coin. You did nothing with it, so it's a valid transaction. No one challenged it for at least a week. So that's why there is a 1 week delay implied. And then if you want to withdraw it immediately, you burn your coins, and then there is smaller extra delay.
Okay.
So it's not like 100% immediate. There is much smaller extra delay.
I see.
It's mainly for user convenience. And still, in this period, you can be challenged by normal rules that it can be a double spend in Plasma in principle. For example, if you burn your coins and you somehow colluded with the Plasma operator and the Plasma operator allowed to make another transaction for the same unspent output. So we just have two separate delays. One is like 100% should pass for 7 days. So just to challenge any transaction for being invalid. And for this like quasi-instant exit, you voluntarily burn your coin, so you send it to 0 with no private key. And so there is much smaller delay for everyone to challenge that you never double spend it. And also you prove that, well, that you had an ownership on it. It's described in our, well, I send a link to our GitHub. It's described there much better in written. So you can think about it, and I will try to clarify it there in written as much as possible. But basically, this is just some extra functionality for users so they can just withdraw it quicker if they didn't tie their funds, for example, for a month and want them just for some other use on the main chain. Nothing more than a convenience, can be easily removed, but still we would like to have some kind of such mechanism so the user can just have a quick access for their funds.
Okay, it sounds like, okay, definitely I'll take a look and maybe loop back on the next call. My perception is if the functionality is whereby you are essentially locking up, basically immediately producing a withdrawal message on the main chain, and then in the child chain, those funds are now not spendable. And during that delay, you can later on withdraw at any time. I think that can work, but I'll double check the mechanism. But if you are putting a message on chain and there is a delay, then perhaps that can work. Yeah. Okay. Cool. That's interesting, and I'll definitely check it out.
Yeah. I also try to do one more step from minimal viable Plasma. So just the transaction structure is a little bit different. It also will be described in details. It's just a little bit more nested than on my minimal viable Plasma. So we can just iterate inside an RLP encoding. So just a little bit of convenience and generalization. So in principle, it would support more than 2 inputs and 2 outputs, but otherwise it's just the same. So
that could be interesting.
A little bit more strict.
Oh, cool. What are you using RLP for?
Well, just for every input, encoding separate RLP, so we lose a byte. For an output, we also put it as separate RLP, and so arrays, just a little bit more formal than minimal viable. I will also put a clarification,
So you're pre-adding in basically a size of the vector or whatever it is.
Yeah.
Okay, cool. I guess maybe maybe you could end up adding.
Yeah, I will need a day to put clarification in written, and then I would be grateful if everyone can quickly review it for security issues. Otherwise, it follows the same mechanism for withdraw with well, we written insensitive for withdrawal, so you just walk a little bit like 0.01 of Ethereum. So if you're challenged, someone gets it. It's written. Please take a code if you need and just use it. Yeah, if there was any.
Could you share the link?
Yeah, I will post it in the chat just after I finish.
Okay. Oh, and it's quick. I guess maybe quick. I guess logistics question. Carl, is there like a way to like have the maybe links included maybe in the YouTube comments or something like that? I think that could be good. I think there's maybe 1 or 2 links last time, but it's just like maybe as like a convenience type of thing.
Yes, absolutely. I will add them into the video.
Cool. That way it's like easier. Does the recording include the chat history for your convenience?
I can download it after the call. So
no, I mean like is a chat history included when you click?
I think it is actually.
It's saved
Chat history is recorded.
Yes, it's just saved separately as text file. Yes, and just in case if anybody has some ideas about withdrawal mechanism, how we can improve that, or any other ways to do that, so I would like to discuss the things. So
cool.
Everybody.
And then I guess people on the consensus and L4 teams. I know you guys are like very early in getting started on this, but is there anything that we could be helpful with in terms of, you know, getting up to speed, getting like, I don't know, infrastructure maybe review and figuring out like integration points of what like people are working on right now? If you guys are interested in doing different contexts, like let's say enterprise stuff, building on top of the existing Solidity work of other teams, I think like, you know, I think it is more of an open question of like, is there anything?
But probably next week or the week after, we're going to have a section in our paper relating to Plasma that we'd love to get some feedback on, but not this week.
Okay, cool. And Liam, sorry I haven't been like that responsible with email. I think we need to open up a separate discussion on state channel stuff too.
Yeah, whenever you get time.
Okay, cool. Yeah, I think what you guys are doing with state channels is really, really cool. And then the consensus team, Shahan, is there anything we could maybe be helpful with or thinking when it comes to the?
Hi, Joseph. Thanks for the question. We don't have any questions at this time. We're still, as you said, pretty early. We're still trying to get people looking at the code. Ben's close look at the code. We need to make more progress on that front.
Okay, cool. I think, yeah, definitely. It'd be cool if you guys, I think like can get more resources to help out with this. I think you guys have done great work, and yeah, it could be fairly interesting if like some interesting team develops out of that. Is your team spread out, or is it like geographically centered around Brooklyn or anything like that?
It's very distributed from West Coast US to East Coast Australia and New Zealand.
Okay, cool. London. Oh, okay. Is there someone from Australia on the team? Because like I think right now we're sort of pegging the time schedule to be like, how do I put this? Not the call, to be like, basically we threw, I think, Australia and Hawaii under the bus. So is that okay?
Ben is in the UK. I'm in Toronto.
Okay, cool.
Time works for us.
Okay, sounds good.
The Taiwan team actually may do well for, you know, either putting the call a little bit earlier or significantly later.
Okay.
But we can figure that out. I'll talk to Vitalik and stuff.
Okay. I may be able to do, well, I can do just not sleep and do 4 hours earlier. That's an option.
That's nice.
But yeah, we'll figure it out. Okay. In terms of, I guess are there any remaining questions?
So I just threw together, I'm going to go out on a bit of a limb here. I just threw together a little diagram of that prepare commit, or maybe that's the wrong way to say it, thingy. And maybe this will be useful to just like kind of help out. So like A is sending money to B, and please correct me when I'm incorrect. Joseph. So A is sending money to B, and this gets included in the like plasma chain, right? Then B cannot send the money yet. And so we have to wait until this block hash is added to the actual main chain, you know, Ethereum, whatever. And then Sunny, could you, let me mute you. Haha. I muted you. So now A is sending an attestation to B because A was like, oh, I see that it's in the main chain. That's, you know, things are great. And now B sees that attestation and now can send A's funds, including A's commit. And so that commit is something that, that attestation is maybe part of the transaction message. And that's what Vitalik was saying. So.
Yeah. And additionally, I guess one open question is sort of, obviously B now has A's attestation, but everybody doesn't as well, right? Like, so essentially there's two options here, right?
Well,
at least two. Sorry?
Sorry, I mean, I just wanted to point out that there's no theoretical necessity for anyone other than B to have A's attestation.
But in order for B to spend those coins,
correct.
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 At that
yes,
point, B needs to include it as part of B's transaction to, let's say, C. I think that's one option we can do. What do you think?
Yeah, that was the one that I was thinking of.
Okay. I guess that's the most compact way, but the trade-off is that B must have it locally on disk. The question is, should we have a message for B to dump it on the chain before B starts? Is that worth it?
I suppose what we could do is allow like A to send the confirm to the plasma chain operator, and then the plasma chain operator could also hold on and like basically we could have A broadcast it through the network, and then a bunch of through Whisper and a bunch of nodes would keep track of them.
What if B can't even receive it?
Like the point is that someone has basically the way to think about this, right, is that ownership of a coin is mathematically defined by basically if everyone tried to exit, who would win the challenge response game. So if B does not have the confirm message, then A would be able to exit, and B would not be able to challenge. If B has the confirm message, but B hasn't sent it yet, then like theoretically B could still pretend not to have it and not challenge, but that would not be a direct threat. But if that confirm message is public, then at that point, like if A tries to exit, then A can be successfully challenged by pretty much anyone, and so A doesn't have the coins anymore.
Yeah, that definitely makes sense. Yeah. Okay, cool. Yeah, Carl, that definitely sounds like, wow. What application are you using for that?
Draw.io. Everyone, download it. It's the new Google. Also, the other tricky thing, by the way, I think there are two tricky things, right? There's the prepare commit or attestation thingy. And the second tricky bit to get your head wrapped around the MVP, minimal viable plasma, is the fact that there is no proving that like blocks are invalid. It's actually based on the withdrawal periods and like who's allowed to withdraw when. Right. And so like the second kind of confusing thing is like, okay, you don't actually have to prove that a block is invalid, because we make this assumption that if a block is invalid, then all of the users who have coins on that network are going to submit withdrawal transactions the moment, you know, that block is included, and that invalid block is included, and their withdrawal transactions are going to be processed before that block is actually, you know, able to affect anyone's state. And so this is like, that's another confusing thing, just FYI, as you're reading the paper, hopefully that helps a little.
Cool. Any other questions? I guess we can sort of conclude this call. There's no further questions.
Is there, do we have like links of all the GitHub repos where all the teams are working on Plasma?
Oh yeah, we should do that. Okay, I guess we'll do that as part of the YouTube video or something.
Absolutely.
And
That'd
maybe
be
send a link to Carl of your repo, and that way you have a copy. Okay, any other?
I think Ethereum / Plasma could be a good place for everyone for us to kind of link resources and discuss ideas in an ongoing fashion. There's also an Ethereum Plasma Gitter channel where we could all collaborate as a group, which could be pretty fun.
And I think ETH research is another place.
Yeah.
Okay. And anything else?
All right. Well, if nothing else, thank you everyone for the call. Today is actually Vitalik's birthday, everyone. So I think we need to celebrate a little bit and, you know, do the happy birthday to you. Happy birthday to Vitalik. Happy birthday, dear Vitalik. Happy birthday to you.
Well, thank you guys.
You're the best, Vitalik.
Wow, latency on this thing really makes it hard.
I know, it was so much fun. It's going to be a real experience. Anyway. All right, thank you everyone for the call.
Okay, thank you. Bye.
See you in 2 weeks.
Bye, guys.
Bye.
Bye-bye.